All right, friends. So for the last video today, I would like to dive into this idea of how we sample all of these different sediment types, right? So we looked at the classification of sediment types. We looked at what we believe the relative thicknesses to be, and kind of how they're relatively distributed around the ocean floor. But how do we know all of this stuff? And who cares? But of course we care. There's reasons for this, right? So we're going to talk about how there's basically three kind of main types of sampling methods. One could argue that there certainly are more types of methods to take in samples, and there certainly are. But these are kind of the ones that your book goes into, and ones that I want to highlight as a class. And I'll kind of mention some other ways at the end, but those won't be methods that I will test you on necessarily. So we're going to start with the most controversial method that is used or generally had been used before, and this is a process called dredging. So dredging is basically where a net or wire basket is dragged across the bottom of the ocean to collect any loose bulk material and surface rocks and shells and things like that. And you can kind of see what it looks like here, right? So you can see there's these kind of long chains, and they literally just kind of drag that along the bottom. And this is kind of the samples that come from that, right? So they're bigger rocks. It's not like that fine, that clay-y sort of sediment from our discussion before. Unfortunately, it's a very controversial method for sampling, and I want you to think, before I give you the answer, I want you to think about why this might be a controversial method for sampling sediments. So think about the process. It's just a basket or net or chains that are being dragged across the bottom, just collecting whatever's there. Have you thought about it? Maybe pause the video for a second and give it a think. And if you thought that it's controversial because it destroys habitats without any care for what's there, you would be correct, right? So it's indiscriminatory on what it encounters. So there's things that live on the bottom of the ocean, like deep sea coral, perhaps some deep sea critters that live within what we call epifauna. That live, or in fauna that live in the sediment itself, like clams, mussels, worms, things like that. So it's very destructive, and it doesn't have any, there's nothing that is telling it what to get. So it just kind of just go. There's a similar sort of process in fishing, and that's called, oh gosh, of course now I'm going to mention it and not remember what the term is. Trawling, there we go. Bottom trawling. So it's a similar idea, but done with a really, really large net and weights that just scrape across the bottom of the ocean. So if you can, it's best to try to avoid fish that are caught with the trawling method, because if you're buying into it, then you're just kind of allowing that to happen. But that's fishing, that's not sampling, but it's a similar sort of thing. Anyway, but dredging, I do have to mention this because dredging is not all bad all of the time. It's actually good to keep bays clear for ship travel, for cargo ships, right? So take the San Francisco Bay, for example. We have several different rivers that come into the bay, and there's sediments being transported as that happens, right? As we kind of mentioned in our previous videos. So if you have lithogenous sediments coming in through rivers, sometimes it just gets stuck and just gets built up, right? So when it gets built up, it needs to be kind of filtered back out, and dredging is a way to do that. So dredging to keep these regions clear of too much muck and murk and sediment, that's a good thing. But doing dredging for sampling methods is generally not. It's like that meme, it's that kind of thing. Another method of sampling are called grab samplers. So these are little hinged devices that are spring or weight loaded, and they snap shut when the sampler strikes the bottom. These sample surface sediments of a fixed area, so of an area that folks have chosen, at the seafloor at a single known location, right? So it's just in one spot and it just kind of just gets what's at the surface. This you could maybe argue is controversial as well, but it's not as destructive as dredging. So that's why dredging is going to be the most controversial of the three types we're talking about today. The way that you can think about this is like the claw, like those little claw machines in like Dave and Buster's or arcades where like you can go and sample or get like the thing, or like from Toy Story, right? That's like a common analogy for that one. So a similar sort of idea where you're just kind of picking and choosing that little space. The next sample method is generally the most used and is also there's two different types basically. So one is a hollow pipe with a sharp cutting end. So it just kind of falls down the water column, and once it reaches the sediment, then it just goes and goes into the sediment, and then it'll kind of shut off, and then you'll bring it back up to the ship, and you'll have a nice core. So it's forced down into the sediment by its weight. There is, however, also a longer core, which is used with a piston device that actually helps drive the core barrel into the sediment. So there's a little bit more mechanics involved in this one. Oftentimes scientists will they'll look for areas that they're going to do sediment research. There are some certain areas around the world that are a little bit more quote unquote interesting or go along with the questions that they're trying to answer. So they'll try and figure out different regions that they want to take these samples from depending on their science question. So here's just a few pictures of what some of the coring devices look like. This is one of just the free weighted ones. This one as well. And then this one is kind of one like where there's a little bit more mechanics involved. And you can see this one's up in looks kind of like a glacier, right? So they're probably doing some sediment data closer to the polar regions. We're very curious about the polar regions. It'd be difficult to kind of take cores from there though in certain times of the year when it's really stormy, right? So that's another reason why ocean expeditions and ocean exploration expeditions really have to be super keen on what's happening in the weather and with waves and stuff like that, because it's kind of a lot. It can be kind of hard if you're trying to like take a sample and your main ship is kind of going, well, right? So just to give you an idea of what some of these samples look like once they bring them up onto the ship and they start analyzing them. So the cores themselves give the scientists a vertical profile of what the sediment looks like. So as you can see here, basically they can like open up the core almost like a book. So in this image in particular, you can see there's even like some kind of darker, almost pebbles or rocks that are in here, right? So indicating that, there's just different rock types within the main sediment load, which is kind of interesting. And then that they can also do radiometric dating to help determine the ages of the various layers. When we talk further about climate change later on in the semester, we'll see different other types of core samples from the oceans and give you an idea of like where you can actually literally see different layers. It's really quite neat. So this is very, very helpful all in terms of climate change research. So that's pretty well it. The way that you will see a question on your next exam in terms of sampling and sample methods is in a short answer question. I'll ask you to list and describe the different types of sampling versions or sampling types that scientists use and which is most controversial. So do be sure that you understand those ideas. Excuse me. So this is everything that we've talked about in chapter 3. How depths are measured and mapped, kind of which methods are good and which methods are not so good, and we try to stray away from using at this point. And the different features along our seafloor provinces, right? We started near the continental margins, we went into the deep abyssal plain, and then on the mid-ocean ridge. So just some of the features you see along there. And then we finished up talking about different sediments. So the different types of sands and clays and such that we see along these various seafloor provinces, and finished up with the sampling methods. So this is the overall summary from all the concepts that we've covered since the beginning of the semester. So be sure to take a look at this. This is really just copy and pasted from the study guide if you're choosing to use that. So be sure to start kind of getting your thoughts organized, your notes organized if you're using them, perhaps, and start to employ some different study tactics, like starting to rewrite your notes, perhaps. It's just a way to kind of help cement these ideas in your head, even though everything is open book, open note, open resource. Just a suggestion, certainly not going to make you do anything that won't work for you. So with that said, thank you so much for watching, and I hope you have a lovely rest of your day.